All right, Programming 12. Now that we have taken a look at kind of the nuts and bolts of the p vector, like the basics syntax of it, let's see if we can do something interesting with it. So I want to show you how you can rotate a p vector. So what I'm going to do is I'm going to take our velocity and I'm going to just kind of lock it in at a particular speed. I'm going to say 3, comma 0. So what direction is this going to move in? Well, it's like a Vx of 3 and a Vy of 0, right? So Vy means it's not going to be moving up and down, but it will be moving to the left, right. Have trouble with that. Don't judge me. So it's going to be moving to the right. And I guess we'll just see that. Let's just see it in action. It's going to look a little bit funky, I think. It's actually kind of dope. But yeah, everything's kind of just moving in a particular way. I kind of love it, It's like, what the heck? I don't know. It's kind of beautiful. Like all things in programming, like, I don't know, you can't make a mistake. It's just beautiful. I mean, yes, you can make mistakes, but I don't know. That's cool. So that's not really what I want to show you, although it's interesting. What I do want to show you is how we could make everything still stay moving at a speed of 3, but give it a random direction. So treat them separately. So what I can do is, after I've set my speed to 3 and they're all going, the same direction, I can now rotate them randomly. So I can say velocity equals, velocity dot rotate. So rotate is a function that lets you give it an angle, and I could choose an angle. It works in radians, so feel free to use the radians function to translate from degrees. And remember that because the y-axis is upside down, normally circles in math, trace out this way around the unit circle, but ours are going to go this way instead because of the upside down y-axis. So if I said 45 degrees, which is, pi over 4 or whatever, then we're all going to go rotate down that way. But it'll still have the same speed. Let's just see. Is this true? Oh, it is true. Look at that. And cool. that's really pretty. I don't know. I really like what's happened here to our sketch. But yeah, everything's moving now at a 45-degree angle. We could have done this without too much trouble, but now I can guarantee everything's got the same speed. And I can even randomize. Oh, that looks so cool. I like it. We can even randomize this. We can, we can make a random number between 0 and 360 if you want to work in degrees. Oh, something like that anyways. Now they have a random direction, but they're all going to move at the same speed. This was something we desired to do back in the day. Remember the clicker game? Sometimes when we ran the clicker game, we would get a fast moving clicker, and sometimes we would get a slow moving little clicker thing that's moving around the screen. And it was very inconsistent, but that's the only way we could get a random direction. So now we can randomize the direction and keep the speed the same, and vice versa. We could even keep the direction the same. So I could say, you know what, we're going to have always 45 degrees, but we can make some faster and some slower. So I can just make a p vector that goes straight out, and then we just kind of rotate it around the circle. So I could say, you know what I could do? I could even make a 0, 0. Actually, I'll mention another function where you can set the magnitude, which is essentially what we're doing with this 3. Like I'm saying, this is a line from 0, 0 to 3, 0. That's 3 long. That's like the magnitude, and essentially is the speed if we're using the p vector as a velocity. So actually, I can set the magnitude as well. So whatever it was, we could just set it to 1 as sort of a unit vector kind of thing. I can just set that magnitude to a random number. So I can say random, I don't know, we could go from 1 to 5. So now my magnitude is random, and I could have just plugged this in here, but I thought I'd show you set mag because it's kind of cool. Now we can see, oh, look at that. We're always going to be moving 45 degrees, but some will be faster and some will be slower. So we get this kind of thing going on, which is also kind of dope, and I really like it. I think it's cool. So yeah, some are slow, some are fast, but they're all kind of moving in the same 45 degrees. Of course, once they bounce off the walls, they're moving in different directions. But that's cool. Look at this lonely guy. Oh, finally he's got a friend. There we go. No, he's leaving. Oh, but he's going to make so many friends over here. Oh, it's so beautiful. Okay, enough of that. But do you see we have set, mag, and rotate, and how that separates the speed and the direction? You know, it really allows us to kind of access those components separately and do some cool things with those. There's some other things we can do with PVectors too. Most notably, we can get the angle that we've rotated to of a PVector, and that might be useful down the road. But I think we'll leave it here as like a demonstration of some of the fun things you can do with PVectors. I'll leave it up to you to how you want to leave your how do you want to leave sorry, how do you want to leave these things, and you can kind of play with it a bit more before you move on to the next video, just to see if you understand the difference between the Vx and Vy versus PVectors, and how we can, you know, set magnitude and we can rotate as kind of two separate things, and that allows us to have more control over the movement of our movers. Hey, thanks everybody. I'll see you in the next video, where we're going to talk about converting over to an array list and how that will allow us to create movers dynamically, and what that means. Stay tuned to the next video. Thanks, Programming 12.